Going to spend one more day on absolute value equations and inequalities. These are all put together, so make sure that you're watching the sign that's actually happening. This is the way that the test is going to show up. Well, when we look at this, we're going to put your answers either in set builder or in interval notation. So we're taking this one step farther than just finding the answer. So we'll do a couple of the inequalities and a couple of the equations, and then we'll take a look at the differences here. So the first one, almost all of these are going to have an absolute value that is not by itself right away, so you're going to need to get it by itself. So I get the absolute value of v plus 1 less than 2 minus 1 is 1, not 2. Now the absolute value is by itself. I'm going to split this. So I get v plus 1 with a negative 1 to the left-hand side, and I have to switch the inequality. And I get the v plus 1 less than the positive side, which is the 1. Now I solve this by subtracting 1. I get v is greater than 1, negative 2, subtract 1. V is greater than negative 2, and subtract 1, v is less than 0. With inequalities, remember that I'm looking at what this is. This is a less than equation. Okay, so it's an and. So when I put this in interval notation, I've got this v is greater than negative 2 and v is less than 0. I'm talking about an and equation. So my interval notation is going to look like this. I've got open circles, which is a parenthesis, at negative 2 going up until 0, where there's also a parenthesis. My set builder notation, thinking back to set builder notation, if you wanted to write it this way, I've got v such that v is greater than negative 2 and v is less than 0. That's one way to write it. Otherwise, if you wanted to write it this way, you could do v such that, not x such that, the variable is v. So v such that the v is between 0 and negative 2. With an and equation, that would be an acceptable way to write that as well. So any of those three that are in blue and green would be just fine for the set builder or interval notation portion of this. When you're taking the quiz on this, that's what your quiz is gonna look like. I'm gonna ask you for the set builder or the interval notation. Well, we'll skip down a little bit here. Number 5 has an equal sign, but I'm still looking at it the same way. I want to get the absolute value by itself. So I'm going to multiply by 3, so I get 2x plus 7 with the absolute value is equal to 15. Now the absolute value is by itself, so I can split this to the negative side and to the positive side. Go through and solve it. Subtract 7 from both sides. 2x is equal to negative 22. Whoops, subtract 7 from both sides. 2x. Smartboard's frozen here. 2x2x is equal to 8. We're dividing by 2, so I get x equals negative 11. Divide by 2 and get x equals 4. So negative 11 and 4, when I look at this problem, if I want to put those in interval notation, I am really looking at a situation where interval notation just isn't really going to work, because I've only got 2 points. I don't have the connection between them. The connection between them is caused by the inequalities. And so I can't do the interval notation. I want to do x such that x equals negative 11 and 4. So that's going to be fine for your set builder notation. You need to do set builder notation. There's no option with the equals. Let's go to number 6 here quick. I've got negative 4 times the absolute value, so I want to divide by negative 4. When I divide by a negative, the inequality has to switch, and 8 divided by negative 4 is negative 2. Now I've got an absolute value equal to negative 2. You guys get me in the habit of saying undefined, but I would rather say that this is no solution. There are no solutions that will work, no numbers that we could plug in for x that after we took the absolute value would come out to be a negative number. So those numbers are still existent here. Let's take a look at one greater than problem. In number 15, I'm going to subtract. I don't want to do that one. That's going to be a no solution. In number 13, let's do 2x plus 3.5 less than negative 11.5 and 2x plus 3.5 greater than 11.5. So subtract 3.5 from both sides. 2x less than negative 15 here, divided by 2. X is less than negative 15 halves. Now you could turn that into a decimal. That would be fine. I don't have an issue with decimals, and you shouldn't either. Subtract 3.5, subtract 3.5. 2x greater than 11.5 minus 3.5 is 8, divided by 2, and x is greater than 4. Now I've got a great or, so this is great or, so this is an or graph. When I put that in interval notation, I'm looking at all the numbers that are less than negative 15 halves and all the numbers that are bigger than 4. And so there's parenthesis because there's no line underneath. If there was a line underneath, I would do a bracket. So parenthesis, I'm going from negative infinity to negative 15 halves. And then I'm also going from 4 to infinity. So I would have negative infinity to negative 15 halves, or 4 to infinity. Those are the two intervals that I have. Again, you could write this in set builder notation, and that would be fine. We've got x's such that x is less than negative 15 halves, or x is greater than 4. There's no real better way to write that in interval notation, or in set builder notation, as opposed to where interval notation could fit in. So an OR graph looks like that, and graph. Make sure that you're paying attention to whether it's an inequality or an equality, and then take your time to go ahead and double check to make sure that the answers are working as well when you're going through.